Okay, here is the second part of the video. I did this before and it failed when it uploaded, so we're going to try again here. This one we did in class already. Here you notice there's what, adding and some multiplying. This one only has multiplication with an exponent, and the one we did in class only has multiplying in it. So think about what the inverse operation would be. What would be the reverse? Try to solve all these for the given variable, and I will come back in a few minutes. Okay, so let's look at the first one. We're solving for t, which is over here. It is being multiplied. So to undo multiplication, you would divide. So I'm going to divide by the thing I want to get rid of, which is that r. And so notice they cancel, they equal 1. So t, which is time, equals distance divided by rate. And that's one that I did earlier in the first video. Sometimes this is a much handier formula than what you're given, okay? This one, notice, what does it have in it? I notice it has, if I knew what all these variables were, what numbers they were, I would multiply first and I would add second. So I am going to go backwards. So I'm going to undo that. Now I want to solve for r, which is in this chunk right there, in that term. So to get rid of adding p, I'm going to subtract p. Okay, and I'm going to write bigger over here. So I have a minus p equals, and then what's left? PRT. Okay, and then now I want to solve for r, so there's only multiplying over here. So now to get rid of only multiply, I can only divide. So I want to get rid of what? The p and the t. So that's what I'm going to divide by. To get rid of multiplying p and t, I'm going to divide by p and t. So notice these cancel, these cancel. When I divide, I get 1 on those. So my rate equals, and this is a p over here. So I could write a minus p all over, what is that, pt? Okay, and there's a minus in there, right there. If you can't see it, I guess I could erase it and try to make it look a little bit better. So minus p. There we go. Okay, the other thing is I can divide each piece. So you can't just cancel or anything. You can never cancel unless you have factors, like all multiplication, right? If you have some add and subtract, you can't do that. But I could do, let's see, kind of, we talked about that little heart thing. So I could divide each piece by that. So r equals, what is it? A over pt minus, and then here, when I divide this one, the p's would cancel out, but there's going to be a 1 left on top over t. So either one of those are okay. And again, it's only okay to do this kind of when you have add and subtract divided by a single thing. Kind of like if you have 396, it's kind of easy to divide by 3 because you're dividing a multi-chunk, right? This is adding, this is really 300 plus 90 plus 6. And so I can just kind of divide each piece and it's kind of easy to divide. That's not true when it's the other direction. So if I have 3 divided by 46, that is not nice, and I have to do long division on that. So it's only when you have a single term that you're dividing by that you can do that. All right, let's look down here. Order of op, if I knew what r was, what would I do? I would square first, and I would multiply second. All right, but I'm going backwards, so that means I'm going to divide first. So I want to keep the r, so I'm going to divide both sides by 4 pi. So I get what? S over 4 pi equals what? R squared. Okay, and then to get rid of squarine, I need to square root. So I'm going to see if I can switch colors here and still see it. So I'm going to square root both sides. Okay, squarine cancels square root in their inverse operation. So I get the square root, let's see, S over 4 pi equals R, or R equals, either way. Okay, now usually again when you have a squared you get 2 answers, a positive answer and a negative answer. So like for example, if I give you x squared equals 81, you would expect 2 answers. When you square root, you would expect plus or minus the square root of that. So plus or minus, so a positive 9 or a negative 9. But in this formula, we're dealing with r, which is the radius. This looks like it's the formula for the, let's see, what is that? Surface area of a sphere. So if you had a sphere, like kind of like a ball, like a three-dimensional here, and you wanted to like paint it, how many square foot of paint would it take, or something like that, that you're just covering it with no overlapping. This is the surface area formula for a sphere. This formula up here is for the total amount for simple interest with the principal. P stands for principal, the amount you borrow or save. R is rate, T is time. So this would be the formula for your future value if you had simple interest and including the principal. And then, of course, distance equals rate times time. All right, why don't you pause and try number 4 on the next page. So read example 2 and then try number 4 and I'll catch up with you there. Okay, so my neighbor decided to mow their lawn on top of everything else. So, but I've remade this video before and I'm kind of like, well, we're just going to get it done. So, all right, say I ask you to graph this. 6x plus 3y equals 15. You can always make an input-output chart, but that can always take some effort, especially if this is called standard form when it's just kind of ax plus by equal number form. So this is standard form. So like, for example, if you sub in 0 for x, that means you're going to have to do some math. So you're going to substitute in 0, 6 times 0, you're going to get 0. This isn't too bad. You're going to get 3y equals 15 because this is going to go away. Divide by 3, and you're going to get what? 5? Okay. But then say you're like, okay, that's only 1 point, right? So then you're like, okay, I need another point. So then maybe you're like, all right, fine, I'm going to sub in 1. And so you're going to input a 1 and you're going to get 6. And then notice you have an algebra equation here that you have to solve. So I'm going to subtract my 9. I'm going to get what? 3y. Did I say subtract a 9? I don't know why I said that. Subtract a 6. So subtract 6 because the answer is 9. How's that? And to get rid of multiplying, divide. So I get 3. And that's 2 points, which is enough to graph. But happen if I messed up on my math, I'm like, ooh, I really want to plug one more point in there just to be certain that they all 3 line up. Because if all 3 line up, I'm going to feel really good. If 2 line up, I might be off. So I'm going to sub a 2 where the x used to be, which is a 12 plus 3y equals 15. And again, I have to solve for y. And so notice I just keep solving for y over and over and over again. And that's a lot of work. So get 3. Divide by 3, it looks like it's 1. And I could plot these. So 0, 5 is up here. 1, 3 is right here. 2, 1 is right here. And I could draw my line. And I don't know how straight I can draw it with a mouse, but there you go. And then if the question says find the y-intercept, it's like, oh, it's right there. The y-intercept is 0, 5. And find the slope. Well, let's do rise over run. If I take this point, I rise 2, go backwards 1, rise 2, go backwards 1. So it looks like the slope is a -2. And do they want anything else? I think that's the main thing, okay? But notice the directions say solve. Okay, so this was a lot of work over here. It helped us get the y-intercept. It helped us find the slope. It helped us graph it, but there's an easier way. All right, so we are going to do the easier way. Instead of solving this equation over and over and over again so I can get some points, what we're going to do is kind of how we started class. We're going to solve it once because that format of that formula or that format of that equation is just so much user-friendly, kind of like the distance, rate, time one. So I have 6x plus 3y equals 15. So I want to solve for y and get it in y equals mx plus b form. So notice we have multiplying and adding. So I'm going to get rid of adding first. So I'm going to subtract 6x from both sides to get rid of that. Okay. And then notice when I do that, these cancel. So I get 3y. And I'm going to put the negative 6x first because I want this in y equals mx plus b form. And then to get rid of multiplying, I'm going to divide. And I'm going to divide by each piece, just again, so I get it in y equals mx plus b form. So the nice thing is now this formula is super friendly for input and output. Okay. So even if you want to make a chart, if you love making charts to graph, notice that this chart is way easier to fill in. Because now that I've solved for y, if I sub 0 in, I just do the math in my head, I get 5. If I sub 1 in my head, I get -2, I get 3. Or I can type it in a calculator too. If I sub in 2, I get -4. It looks like that's 1. So I don't have to solve for y over and over again because I just solved for it in the beginning. Okay. The other cool thing is, notice I can see my y-intercept. Here's my starting amount. So I know my y-intercept is at 0, 5 without, by just solving it. And then do you see how your slope is always in front of your x? So I know my slope is a -2. Okay. Now, the other cool thing about this is you can graph this without even making this chart. So if you understand how this equation works, you don't even need this. Your starting amount is 5. So go to the y-axis and put a dot at 5. So there's my dot. Now your slope is not a point, but it's a kind of a point factory. It's a point creator. And I'm going to write -2/1 or 2/-1. Both of those are equal to a -2. And I'm going to put in rise over run format. So if I go rise 2, I can go backwards 1 and put a point. Or if I go down 2, I can go to the right one, put a point, go down 2, put a point, go down 2, over, put a point, go down 2. And so what your slope does is it starts at your y-intercept, and then you can use that rise over run to create infinite many points. And then you have your line that way. And you don't even need to make the chart. So solving for y is super, super helpful because this format is so much more useful than the other one. All right, let's look at this next one. I'm not a big point slope person. Some people teach this because I guess they think it's easier to do, but I'm going to pause this and clean the board, and then I'll come right back to this. So go ahead and read 5, part A. Okay, so in this one, what they're doing is they're saying, hey, there's another formula you could use too. So remember how slope, you subtract the y's and you subtract the x's. The only difference is, notice it's usually y2 minus 1, y1, x2 minus x1. They just left the 2's off this time. And what you can do is you can put a 1 under this and you can cross multiply. And so this formula, if you manipulate this guy, you're going to have x minus x1 times m equals to y minus y1, because that 1 doesn't do anything to it. And so this is called point slope form. And so if you want to use that, then you can solve equations. And usually we write this in this format. So we put the y minus the y1 first, and then we put the slope, and then we put the x minus x1. And so we can solve equations using this formula as well. You just sub in your y1, your x, your slope, and then you have to distribute and bring this over, and you can get an equation that way. So I'm going to pause. Go ahead and let's look at page 385. Okay, some people love this for writing formulas. Do you see how you have an input and output, and you know m? So your y minus stays, and your x minus stays. And then the rest are fill in the blank. So my input, what's my x, is 2. My output is my 5. And then what else? My slope is my 3. Okay, so I'm going to use a distributive property. So I get y minus 5 equals, what is that? 3x minus 6. And then I add 5 to both sides. And it looks like y equals, what is that? 3x minus 1, if I didn't make a dumb mistake there. Okay. All right. And then let's try doing it C. C is the way we've normally been doing it in class. So try C, so see which one you like better. I'm going to pause here. You try it. Okay, let's look at the way we normally do it. So normally we just write the equation y equals mx plus b. I like this because most people remember it. Then I sub in my input, my output, and my slope. So I know 3 out of 4. And then I just solve for b. So I get 6, subtract 6, I get b equals a -1. And then remember, you just fill in the blank. So you know the slope always is the rate, and that always goes before your x, and you know your y-intercept is the other number, that's your b. And so to me, I prefer that because this is just something else to remember, and it's just easier to remember y equals mx plus b. But that's your choice. You can decide. All right, we're going to stop there. Keep plugging away.